Hello everyone, welcome to the Information Network Security lecture series. This is lecture number 2. In this particular session, we will study this topics. That is, the first one is cryptographic algorithms and protocols. Then we have symmetric cipher model, symmetric key cipher technique, then Kerckhoff's principle and cryptanalysis. So we'll start with the first topic, that is cryptographic algorithms and protocols. Now we can actually group all the cryptographic algorithms and protocols into 4 main areas. Okay, the first one is the symmetric encryption. Okay, then we have asymmetric encryption, then we have data integrity algorithms, then we have authentication protocols. Now in case of encryption, as we have symmetric encryption, so in this symmetric technique we encrypt the data with a key and decrypt the data with the same key. In asymmetric encryption, we encrypt the data with one key and decrypt with another key. Okay. Now, what is the meaning of encryption? Decryption we'll see shortly. Then the third is data integrity algorithms. Data integrity algorithms are those class of algorithms which can be used to maintain the integrity or check the integrity of the data, of the information. Okay, if someone is sending the data, okay, and receiver can check through the data integrity algorithms that whatever data which was sent is received the same, whatever sent was received or not, is there any change or not. Okay, so this is the data integrity algorithms. It checks the integrity of the data. Then we have authentication protocols. Authentication protocols can be used to authenticate. Okay, as the word authentication is, like suppose if Alice is claimed that I am Alice, then how she can claim that she is indeed Alice and nobody else. So we can have this authentication protocols. Okay, then this is a symmetric cipher model. Okay, first we'll study in the symmetric cipher techniques, and then we'll go for the asymmetric one. So in symmetric cipher model there are 5 components. Okay, as we can see, a symmetric encryption scheme has 5 components. First is the plain text, then we have encryption algorithm, a secret key, a ciphertext, and decryption algorithm. Let us understand this with a diagram. As we can see, the diagram is here. Now we have the first component is the plain text. Now plain text is the message in which can be easily readable and could be understood. Okay, so like here whatever we written on this page, we can see encryption, we can read and understand. So plain text is the data or the message in clear text, anybody can read and understand. Then at the sending end we have the encryption algorithm. So there are varieties of algorithms, one of them we can use. Okay, so this is the encryption algorithm, okay, through which data is encrypted. Okay, encrypted means what? It is converted from plain text to ciphertext. Okay. Then we have a key. Okay, so here we have the secret key. Okay, now this key it is not a physical key. Actually it can be any number. Okay, it can be anything like some bits, a combination of some bits, okay, or any other thing. Okay, so we'll see what is the meaning of a key. Okay, then we have the ciphertext. Okay, now ciphertext is the text which cannot be easily which cannot be actually understood. Okay, so it is in some coded data. Okay, it is some coded data. Like suppose if I write hello here, now this hello is a plain text message, we can read and understand what does it mean. But if I write something like Z X P Q R, now this does not make any sense. So we can say this is the plain text and we can say this is the ciphertext. Now this ciphertext is sent through a medium. Okay, and it reaches the destination. This is the destination part. Okay, so the ciphertext is received by the receiver. Okay, the receiver uses a decryption algorithm and the same key. You can see this key is same. So the thing in symmetric symmetric algorithm is that the key which is used for encryption, the same key is used for decryption. Okay, so at the receiving end we have the decryption algorithm, and by using this decryption algorithm and the key, the plain text is recovered. Okay, so this is how this particular model works. Then we have symmetric key cipher technique. This is one more way. Okay, there's a more generalized diagram. So here at the sending end we have Alice. Okay, she has the plain text, she want to send the plain text to Bob. So what does she do is she uses a encryption algorithm and a secret key, and this secret key is shared by them. Then she makes this plain text to ciphertext using this encryption algorithm and the secret key, and sends this data. Now, as you can see, there are two channels. One is the insecure channel and other is the secure channel. So through the insecure channel, she sends the ciphertext. The ciphertext is received at the Bob's end. Okay, Bob uses a decryption algorithm and the same key which was used. Okay, and then the plain text is recovered by Bob. So here we can see there are two channels. One is the one channel is, that is what we have, is the secure channel, where the key is exchanged, because this key has to be exchanged. Okay, it can happen that either Alice generates this key or Bob generates the key, and they need to share the key. They must have this key, and this key is very, very important. Okay, and they have an insecure channel by which they share the encrypted data. They share the ciphertext. Now in case, suppose if through this insecure channel, now why it is called as insecure, because anybody can access this particular channel. So if, let us suppose, if Eve gets an access to this insecure channel, if she intercepts this ciphertext, she cannot get the plain text unless and until she knows the algorithm and she knows the key. Okay, but since it is assumed that the Eve does not have the key and does not know the algorithm, she cannot decrypt the data. Okay, then we have some principle called Kerckhoff's principle. Now what this Kerckhoff's principle say, that the security of cryptographic algorithm must depend on secrecy of the keys only, and it is assumed that the adversary, the attacker, knows the algorithm. Okay, so in this case also, with the previous case what we saw in this case, so if there is an adversary, suppose if there is an attacker, like suppose Eve, okay, so it is assumed that Eve knows this algorithm. Whatever algorithm Alice and Bob they are using, the attacker knows the algorithm, but attacker does not knows the key. Okay, so does not knows the key means that if the key is secret, then this algorithm is okay, and if the key is not secret, okay, so our main focus in designing symmetric key cipher is to make a strong key. Now what is the meaning of a strong key? Okay, like suppose as I told that this key can be a number. Now if the number is suppose of one digit number, so one digit number can be either 1, 0, 1, 2 up to 9. So there are 10 numbers in this case. Okay, so in this case Eve will require just 10 attempts to crack a key. Okay, now suppose if Alice and Bob they decide that number 1 is the key. Okay, key is number 1. Okay, number 1 is the key. So there are 10 numbers, so any of this 10 number can be the key. So Eve will require just 1 out of 10 attempt will be, so the success rate would be 0.1. Okay, so in this case what we say is 10% success rate can be achieved by Eve. So this is so a single number is not a good key. Now suppose if we make the number as a two digit number, now 2 digit number can go from 00 to 99. Okay, so there are 100 numbers. Okay, so in that case the success rate would be 1%. Okay, so now this is more secure, as with one number what we saw is that if with one number the success rate is 10%, with 2 digit number the success rate becomes 1%. Okay, with 3 numbers it is 0.1, with 4 numbers 0.01%. So as we see, as the numbers increase, okay, the success rate of the attacker decreases. Okay, so the key should be as long as possible. Okay, it cannot be like when we're using the ATM pin number, it is of 4 digits. Okay, so 4 digit means was the attacker needs to type all the numbers from 0000 to 9999, which makes about 10,000. Okay, so 10,000 means the success rate is 1 by 10,000, which is very less. Okay, so more the numbers means more stronger the key would be. Okay, so you must keep in mind that the success of the cryptographic system depends mainly on the key. The adversary, it is assumed that the adversary, the attacker, knows the algorithm. So we must try our best possible way to keep the key as secret as possible. Now next comes cryptanalysis. Now what is the meaning of cryptanalysis? That is the art and science of breaking the codes. Okay, so cryptography is the art and science of making the codes, while cryptanalysis is the art and science of breaking the codes. Okay, now there are few attacks. Okay, now as we have seen in this cryptographic symmetric cryptographic model, that any attacker, the attacker can get an access to the encrypted messages. So what the attacker will do with the encrypted messages, these are the 4 things which will be done by the attacker. Okay, the first one is that the attacker only has access to the cipher text. Okay, so we have Alice, we have Bob, and here we have Eve. So when Alice is sending the encrypted message, okay, this message is called a cipher text. So Eve gets access to the cipher text. Now what this is the most common attack, we can say. The first one is the most common attack, that Eve only has the cipher text, she does not knows the key. So what she will do? So these are 3 things which she can do. The first is brute force attack. What is the meaning of brute force attack? She can try all the possible ways to recover the key. Okay, like suppose if the key is of suppose 4 digits, so she can try from all zeros to all 9999. If it is a decimal number, she can try from all zeros to, or she can try all the 10,000 combinations to get the key. Okay, to get that message, okay, recovered from the cipher text. Second is a statistical attack. Now when we go statistical attack, sometimes brute force attack becomes much impossible because the key is very large. So second type of attack is the statistical attack. Now what statistical attack can be done is that in languages, like suppose if we say the English language, in English language we see that the alphabet E is actually this alphabet E is found more in any of the text message, then I is very much found and A is very much found. Okay, so the attacker knows that which alphabet is repeated again in a particular text message for that particular language, and there are some alphabets which are rarely there in the language, like we have X, Z, they are rarely found. So attacker can use this statistics. Then attacker can also launch a pattern attack. What is the meaning of pattern attack? Like the attacker can go for, like suppose if there is a 2-letter word, okay, so the most 2-letter word used in English is is, then 3-letter word is and so on. So attacker can go for that. Okay, so this is the most common attack. Then second is the known plain text attack. Now what is the meaning of known plain text attack? Known plain text attack, what happens? I'll just understand with an example. Like suppose we have Alice, and here we have Bob, okay, and here we have the attacker Eve. So here we have the attacker. Okay, now what happens is Alice has a plain text message. This PT means plain text. She converts to cipher text and sends it to Bob. Bob recovers the plain text because Bob knows the key and Bob knows the algorithm. Okay, now Eve, let us assume Eve knows the algorithm, but she does not knows the key, so she only has this cipher text. Now after a few days, let us say after 1 day, now this this cipher text, now it need not be secret. Okay, so the secrecy was important for that particular day, but now it is no more secret. We don't want it to be kept secret, so this was made public after 2 or 3 days. This was made public. Now what Eve will do, because this message was now made public, okay, so Alice already had a cipher text. Now this plain text was also declared now, because now it is no more, it need not be kept secret now. Now Eve will compare this plain and cipher text, plain text, okay, of the same cipher text, and she will recover the key. She will try to recover the key. Okay, and if next time when Alice is sending the message, okay, and if she is not changing the key, then it will be a benefit for Eve that she knows the key now. Then we have 2 more attacks. These are very much less likely, that either a chosen plain text or chosen cipher text attack. In such an attack, what Eve either gets the access of Alice system of Alice, or the of Bob's system. Okay, she will recover many of the files. She may be having some data, okay, and she will try to match that the data with the data which is on the PC of Alice, or maybe on the PC of Bob, and she can just match the if she's having the ciphertext, she will try to match it with the data on the Alice PC or maybe on the Bob's PC, and she will try to get the key. These are two, of course, very unlikely attacks. The most common is this one. So that is the crypt analysis. So that's all for this particular session. Thanks for watching.